which is why they call it vagus, like vagrant. So it wraps around the aorta. So it has, because embryologically it's up there, wraps around the aorta, and as the heart descends down, it pulls it down. If the vagus nerve is something like a giraffe, it's 15 foot long. And here we go, arch 1, Meckel's cartilage, incus, and malleus. So remember, if you got a problem down here and a malformation of the mandible, you're likely to have, check the ears, you're likely to have a problem there too. Arch 2, the stapes, same thing that the reptile used. We stole the stapes, but we kept it in its own place. That's likely to go wrong if you've got something wrong with the second arch. And the second arch goes to the lesser horns, or lesser cornu of the hyoid. Arch 3 forms the greater cornu of the hyoid. What a weird little bone that hyoid is, huh? And this is just to show what Meckel's cartilage looks like embryologically during, the second trimester. You see there in the blue, that's Meckel's cartilage, and then it begins to, the cartilage around it starts to calcify, and pretty soon it gets smaller and smaller, and the mandible gets bigger and bigger, and finally it's gone. The whole point, and I've mentioned this so many times now, is that Meckel's cartilage does not directly form the mandible. But just remember that. If any of you miss that, I'll kill you. Oh, this is just brains. We've got that. The brain-body growth curve in a human, because we have to get the kid out, does not stop at birth. In other mammals, it essentially stops at birth and it flattens out, like this chip. Not so in humans. We maintain a fetal growth curve all the way till age 6. And that is enormously expensive. 80% of a kid's energy goes into growing its brain. And what is that? Are we adding neurons? No, we're not adding neurons. In fact, we're losing neurons through programmed cell death, apoptosis. You've got more neurons at birth than you have for the rest of your life. What we do is we add glia, connective tissue. What's glia? Fat. So it's very difficult to get enough fat into a kid, because that brain is just stealing all the calories it can possibly steal. That's why, if you know anybody that's worried about atherosclerosis or for whatever reason, and they do not breastfeed and they give the kid skim milk, tell them that's dumb. That's really not a good thing to do. Vegans do that with their children because they think it'll help them in the long run. Well, not for the first 6 years. Please, give them fat. It's okay. What'd you say? Did I insult some vegans?
No, yeah.
I don't care what you eat as an adult, I could care less, but just don't do it to a baby. Speaking of babies, we talk about these, we have to keep these sutures open. So that's the coronal suture, right? We all know that. That's the sagittal suture, we all got that. That's the lambdoidal suture, we got it. What's this one? Squamosal. Got that one. So we have to keep the sutures open. But the longer you keep, the longer it takes to develop anything. Means that the environment has a greater chance, a greater amount of time to perturb it. And because of that, we end up with all of these issues with our cranial sutures fusing too early. It can be due to trauma. It can be due to genetics. But they fuse too early. And that's why kids can end up with all kinds of head shapes that are peculiar. Once again, you can see all those sutures. And what is a suture in terms of it's a joint. And that's where the growth occurs. I mean, you have little pockets here of calcification, but growth in something like a parietal has to occur along its suture. It has Sharpie's fibers that connect the two. And there's bregma, so that's the anterior fontanelle. That was the posterior fontanelle. We also have one here in the sphenoid. Look at this. See that kid's head? Because his metopic suture fused too early. And that's called trigonocrania. When that fuses too early and the brain can't expand laterally, so what does it do? It ends up pushing forward. So you get kind of a triangle frontal bone. This is what it looks like in a scan. That's an early metopic fusion. And the metopic suture in humans doesn't fuse until 3 or 4. And some people it never fuses. As a matter of fact, mine's not fused. If you rub your forehead and you can feel if there's still ridge there, your suture never remodeled away. Doesn't mean, oh, maybe it does mean you've got a problem. I don't think so. But a patent suture. Humans don't fuse our sutures in our skulls until long into adulthood. Oh, that's it. Unless you want to get into this, and I don't think you do. I was going to start in the beginning. Embryologically, you have. So we're not going here. But I will only say one thing. That thing right there is what falls through the pelvic floor. And that's no fun. When your uterus falls through the floor. And that's unique to humans. This is all something different. You guys do know about myelin sheaths and dendrites and axons and all that stuff. Do you know that the modern human brain has in excess of 100 billion neurons? Each one of those neurons has conservatively 1,000 connections. That's scary. That is a scary big number. And we wrap them in myelin so they go faster. Yeah, that's it.